తమిళ్లో ఏమంటారు చెప్పండి.
ఇంట్లో చేస్తారు తింటాం మేడం అంతే.
గజ్జలు.
Okay, I guess its board is visible, right? We'll start the live. Yeah. Okay, so good afternoon guys, welcome to NEET World Institute and NEET World YouTube channel. Yes, so as you know that we have started our IPE preparation for upcoming year, that is 2026, right? And we are going to give a live session for both class 11th and class 12th, like alternative days. Okay, so in last class of class 11th topic, now we were discussing about the work, energy and power, right? So we discussed two questions. I hope the guys whoever have attend the class now have completed the two questions. Now one more question is there in work, energy and power, and then we'll start with oscillation, right? Okay, let's wait for 1 or 2 minutes, like the people are joining over here, right? Okay, so let's begin with the class. Fine. So we have discussed the two questions. The first question was develop the notation of work and kinetic energy and show that it leads to work energy theorem. And yes, we have completed this question. The next question was what are collisions and explain the possible type of collisions and develop the theory of one dimensional elastic collision, right? So we completed the two questions. Now the third question is state and prove the law of conservation of energy in case of free falling body. So first of all we will see what is the question asked. We will try to analyze what they have asked and will split it in subdivision. Okay, so first thing, state and prove law of conservation of energy. So I need to know what is the meaning of law of conservation of energy. Okay, so by using what I should prove, by using free falling body I should prove, by using free falling body I need to prove. So what is the meaning of free falling body? So free falling body is nothing but like I am just leaving the object like this without applying any force on that, like not giving any initial velocity to that. Okay, so what what is the condition here? U will be equals to 0, right, and it will be going towards the surface, that is earth surface. Now what we can say, acceleration will be there, but that is plus g, that is gravity. Okay. So these are the things when we are talking about free falling body. Okay. Initial velocity will be 0 and what is the thing, acceleration will be g. Okay. Because it is going towards down, right. So if I am throwing the object towards up, the acceleration will be minus g, acceleration will be minus g. Now okay, free falling body means we came to understand what is the meaning of that. Now what is the meaning of law of conservation? What is the meaning of conservation? We have studied in last class. No, conservation is nothing but like we are conserving something, we are not wasting anything, right. We are conserving in the sense like I am conserving something from one form to another form, that is it. Okay. Like we can say that energy can neither be created, let me erase this one. Yeah. So law of conservation of energy is nothing but energy can neither be created nor be destroyed, but it can be changed from one form to another form. Okay. I have written here, okay, another form. Okay. So another form in the sense like we can convert that potential energy into kinetic energy or kinetic energy into potential energy. Okay. So we are converting one form of energy to other form of energy, that is it. And the two things we need to know, that what is the meaning of potential and what is the meaning of kinetic. So kinetic in the sense, yes, when the object is moving, we can say object is having kinetic energy. When object is at rest, yes, we can say that object is at object is having the potential energy, which is nothing but a stored energy. Okay. So when we talk about potential energy, rest and it is stored energy, we will say. Okay. When we talk about kinetic energy, object is in motion. Okay. These are the two things we need to know when we are talking about law of conservation of energy, because these two things will help me to derive this formula. Like I need like to prove that law of conservation of energy in free falling body. Okay. Understood the question what they have asked? Yes. So first thing, law of conservation of energy means I need to know. Next one, what is a free falling body? So if I know these two things, yes, writing the answer is very simple. Okay. First thing, law of conservation of energy is nothing but energy can neither be created nor be destroyed. It can be transformed from one form to, or it can be changed from one form to another form. Okay. Either it can be from potential to kinetic energy or kinetic to potential energy. Okay. Understood? Okay. We will go for the next one. So the second point what we should write is the total mechanical energy. What is it? Mechanical energy. Mechanical energy is nothing but it is the sum of potential energy and kinetic energy. Sum of potential and kinetic energy is called as mechanical energy. Okay. Cleared about the first and second point? Fine. Next we will go for the proof. So first let me show the diagram here. Okay. Yeah. So here is the diagram. So in this diagram, no, object is free falling, like object A is freely falling. So object A in the sense, this is my A, like at point A, okay, object is there at point A, it is free falling, u is equals to 0, u is equals to 0. So it is falling, let me take here, wait, it is falling like this. So it has been came to the earth surface. Let me take that point C. In between somewhere I will take point B. Okay, that is the point B. Okay, no. So here velocity will be there. Here velocity will be there. It is not equals to 0. Okay. So the total height the object has been travelled. Let me take it as h. Let me take it as h. If this is h no, and the distance between this is either, let me take x, or let me take this is small h, small h. So, what will be the remaining distance? It is h minus x or h minus small h, right? No, that is it. Yeah. So, this one I will take x and this is h minus x. So, this is the diagram, basic diagram to calculate. I need to find what is the energy at point A, I need to find what is the energy at point B, I need to find energy at point C. So, if I find the energy, like the sum of potential and kinetic energy at point A, B, C, if everything are equal, so I can say yes, law of conservation of energy. Okay. So, Ayush, like it can be conserved and transformed, yes, obviously. So, that is the thing we are going to prove now. Okay. So, like potential energy will be converting into kinetic energy. Okay. So, how I am saying like potential energy will be converting into kinetic energy? No, like I am taking the object to height h. Okay, I am keeping the object simply, like it will be in rest now, right? So, what energy is there? Yes, potential energy. If I leave the object, it will go with some acceleration. If acceleration is there, velocity will be there, right? So, if velocity is there, in the sense object will be having kinetic energy. So, potential energy is converting to kinetic energy. Again, like some potential energy will be there at this height. Again, the total potential energy will be converted into total kinetic energy. Okay. If 5 is here, here also will be 5. Okay. Understood the diagram, right? So, we will go for the first point. So, at point A, so whatever thing we are considering, we should write it. So, we will consider the body which is having a mass m, body which is having a mass m. So, dropping from height h. So, mass m which is dropped from height h above the ground surface. So, when the body free falls, its potential is converted into kinetic energy. So, when I am taking the object to height h, this object will be having potential energy. When the object is hitting the surface, this object will be having kinetic energy. So, in between this, potential will be converted to kinetic energy, right. So, the total energy of a body is sum of potential plus kinetic. So, this is the thing we need to note it down. First thing, the given terms I need to write: mass m, height h, and the total energy will be sum of potential plus kinetic, okay, and the potential energy will be converted into kinetic energy from top to bottom, right. Now, at point A, body is at height h, right, body is at height h, and we know that initial velocity is 0, initial velocity is 0. If initial velocity is 0, no, kinetic energy formula is of m u square or v square, right, no. So, when u is 0, I can neglect this term easily because everything will become 0. So, kinetic energy is 0, right, kinetic energy is 0, right. Now, potential energy, what is the potential energy formula? It is mgh. What is the height we have taken? Capital H. So, mgh is the potential energy. So, we have got u is equals to 0, height is equals to h. When we substitute the value, we will get potential energy as mgh and kinetic energy as 0. So, the total energy Te is nothing but total energy, T is nothing but total energy. So, sum of potential plus kinetic, potential and kinetic is nothing but mgh plus 0 which is nothing but mgh. So, at point A, we got the energy as mgh. Okay. So, next we should see for the second point, point B we need to calculate, right. Okay. So, if you have noted down, we can go for the next one. Done? Can we go for the next one? Okay. So at point B now. So point B in the sense, let me take the pen. Okay. So point B. So when I talk about point B, this is my point A, point B and point C, right. So this one we have considered as x and this one will be h minus x, right. The total height is h and here u is equals to 0, right. That is it. Now when I talk about the height, when I talk about the height, now from the ground surface, the height is h minus x, h minus x. That is the thing we need to discuss, right. Okay. So at an intermediate point, intermediate in the sense it is between point A and point C, we have taken somewhere point B, okay, point B. So height will be h minus x, h minus x. Now potential energy is mg into h minus x. No, I need to multiply this mg into x, mg into h. So what we will get, mg h minus mg x is the value of potential energy at point B, at point B. Now we need to talk about what is kinetic energy, right. So for that we will use the equation v square minus u square equals to 2gh or 2gs. We will write the equation v square minus 2u square equals to 2as is the actual equation, right. And when I talk about initial velocity, it is 0, fine, it is 0, no need to discuss about that. Now when I talk about final velocity, I do not know, v square will be equals to 2 into g into h, that is this distance it has been travelled, right, x, right. No, so why we are talking about this displacement for kinetic energy and this displacement for potential energy. Potential energy means from the ground level I need to calculate, right, and kinetic energy, what is the thing, initially where that point was there and finally where the point was there. So how much distance or displacement it has been travelled, we need to calculate, right. No, so from this point A to point B, the object has been travelled. So this has been travelled x distance. So v square will be equals to 2gx, 2gx. So kinetic energy formula, we know that kinetic energy is equals to of mv square. What is v square? 2gx, no. So it is half into m into g, okay, m into 2gx. 2 will get cancelled, it is mgx, mgx. So what we can understand from here, we got kinetic energy as mgx and potential energy as mgh minus mgx. When I add these two things, kinetic energy plus potential energy, mgh minus mgx plus mgx. So minus mgx plus mgx will get cancelled off. So the final answer will be, mgh. So what we got for point A, it is mgh. What we got for point B, it is mgh. Now we need to calculate for point C. So 2 points we have calculated, 2 also we got the same answer. Yeah, wait a minute. Okay, done. Yeah, so for 2 points we got a same answer. Now we need to check the third point also. If we get the same answer for third point, yes, hence it has been proved, law of conservation of energy, right, in free falling body. When we talk about point C, no, point C, what we can understand from point C here, let me draw the diagram once again here. So this is point A, point B and point C. Point C is in ground. So ground in the sense h will be equals to 0, h will be equals to 0, right. Now this displacement, how much it has been travelled, h, right. Initially velocity is 0, final velocity I don't know, that is not equals to 0, I need to find what is that velocity, right. This is my point A, point B, point C. So, potential energy is nothing but mgh. If h is 0, potential energy will be 0, right. Kinetic energy. So, kinetic energy of m vc square, like velocity at point C, okay. So, what is velocity now? Same equation, v square minus u square is equals to 2as. So, initial velocity 0, final velocity I don't know, v square, I will keep as it is. So, 2 into what is acceleration? Yes, acceleration is gravity, g. So, g, how much displacement it has been travelled? H, right. So, if I substitute the value here, it is half into m into 2gh. So, 2 and 2 will get cancelled off. So, what we will get finally? mgh, mgh. So, that is the thing. So, potential energy is 0, velocity at point C is 2gh, we got. Now, if I substitute the value mgh, we got as a kinetic energy. So, total energy is sum of potential and kinetic energy, 0 plus mgh is mgh, mgh, right now. So, when we talk about point A, point B and point C, like everything are equal, right. So, I can say that energy is constant at point A, point B, point C, right. So, total energy will be constant, total energy will be constant, that is mgh. So, at point A, comma B, comma C, everything are equal. So, hence it has been proved, right. So, this is the third question answer. You have taken down? You have taken? Okay. We will go for the next one. Yes. So, the next one is oscillation. So, we have completed work, energy and power. So, once again we will see what are the questions are there in work, energy and power, and this, if we see the develop the notation of work and kinetic energy and show that it leads to work energy theorem, the first question. And the second question is what are collisions, explain the possible type of collision. So, collision means I need to write type of collision, two types are there, elastic, inelastic, and we need to develop the one dimensional elastic collision, okay, theory of that. And the third question is, yes, state and prove law of conservation of energy in case of free falling body, right. Hope it is clear, work, energy, power, okay. We will go for the next one. Yeah. So, the next one is oscillation, right. The next chapter which we are going to discuss is oscillation. So, in this oscillation also we can expect that 8 mark question, expect 8 mark questions. Okay, we will start the question. Done. So, the first question which we are discussing in oscillation is define simple harmonic motion, show that, wait a minute, yeah. So define simple harmonic motion. Show that the motion of a point of projection of a particle performing uniform circular motion on a diameter in simple harmonic. On any diameter is a simple harmonic. So what is the first point of the question, what they are asking? So first I need to say what is the simple harmonic motion means. Okay, simple harmonic motion. So second, if we see that, show that the motion of a projection of a particle performing uniform circular motion. So I need to say that a motion of a projection of a particle is uniform circular motion on any diameter. On any diameter is simple harmonic. Okay, first thing I need to define what is the simple harmonic means. Second thing, like any motion of a projection, okay, of a particle performing uniform circular motion in any diameter. It can be small, it can be big, okay, and is that a simple harmonic or not, I should prove it. Okay, so this is the equation. So first thing we need to write what is simple harmonic means. So body is said to be in simple harmonic motion if the acceleration is directly proportional to its displacement. Acceleration is directly proportional to its displacement from the fixed point, and is always directed towards the fixed point, always directed towards the fixed point. So two things we should understand: acceleration is directly proportional to displacement and it is directed towards the fixed point. Okay, two points which we need to understand in simple harmonic motion is body is said to be simple harmonic motion if the acceleration is directly proportional to its displacement from the fixed point and is always directed towards the fixed point. Okay, so hope it's clear for the simple harmonic motion. So let us look into the diagram. Okay, so this is the basic diagram which we are going to use in this question. Okay, so nothing, this x axis minus x axis, y axis minus y axis. So initially the particle was here and it has been displaced to point P. Okay, point P. So making an angle theta, so which is going in velocity, that is angular velocity omega, right. So this is the basic diagram of the given question. So now I need to express, look, consider a particle P moving in a circumference of a circle. Circumference in the sense, so the outer part, no, that circle is there, no, that is the circumference, okay, of a circle of a radius a. So the radius of circle is a we have considered with the uniform angular velocity omega. So whenever we are drawing something, we need to express what we are drawing, right. So simply if we draw something, the examiner will not know what you have drawn, right now. So I need to express that. So first point we have expressed. Second point, let O be the center of the circle and x dash and y dash are the two mutually perpendicular diameter of the circle. So we have considered as x axis and y axis as the diameters, that is x and x dash, y and y dash. Okay, so let Pn be the perpendicular drawn to the diameter y dash from P. So this is Pn which is perpendicular to y dash, right now, y and y dash, right. As P moves on the circumference of the circle, N moves on the diameter. So what we can understand here, initially if P is here, N will be here. If P is moving here, N will be moving here, right now. So if P is coming here, N will be here only. If P is coming here, N is perpendicular to the point, right now, N is perpendicular to the point. Let me take that, yeah. So initially P was here, N will be here. Suppose if P comes here, N will be here. That is a perpendicular line in y dash. Okay. Okay. Let us consider the position of N at any n at any time t, so that xop is nothing but theta. Like we have considered here, no, xop is nothing but theta. Like initially point was there, it has been moved, so it makes an angle theta over here, right? Fine. So displacement of n with respect to the fixed point O in the path is given by. So from here we can say that sin theta. What is sin theta in the sense? This is my theta. If this is theta, alternative angle. So opposite by hypotenuse, right? Opposite is ON, hypotenuse is a radius, right? The radius ON by OP, which is nothing but y axis by A. Now from here, this is the main thing. If we write that equation, after this what we should do? Differentiation we need to do. So I will help you here how to do the differentiation. So from here, no, sin theta will be equals to y by A. So y will be equals to A sin theta. So what is theta? Like it is angular velocity into time. Theta is nothing but angular displacement. So we know that velocity is equals to displacement by time. So angular velocity will be equals to angular displacement by time. So theta will be equals to omega t. Theta will be equals to omega t. Right now. So y will be equals to A sin of omega t. So this is my displacement. Right. So that's my displacement. Now if I want velocity, dy by dt will be velocity. So how we need to differentiate? A will be constant, I will keep as it is. Sin differentiation is cos. So it is cos omega t, and what is omega? I mean omega t differentiation, omega we will get, again omega. So A omega cos omega t. Done. Now I need to find acceleration. We are like, what is the thing we have discussed? Simple harmonic in the sense, yes, directly proportional to displacement, and it is, the path is directed towards the axis, right? No, yes, A will be equals to dv by dt, will be nothing but A omega will keep as it is, cos will be minus sin omega t, and omega t differentiation is again omega. So it is omega square into minus omega square into A sin omega t. What is A sin omega t? It is displacement. So A will be equals to minus omega square y. Got it? So A omega cos omega t we got for the velocity, right? So from the equation y is equals to A sin theta, we have written y is equals to A sin of omega t, right? Omega t we have got, how we have got now? So velocity is nothing but displacement by time, this is linear. When we are talking about angular velocity equals to angular displacement by time. So angular displacement will be angular velocity into time. Okay. So from this we got the equation. If we differentiate the equation, we will get velocity. We got velocity as A omega cos omega t. Next we need to find what is acceleration. So acceleration is dv by dt. So A will be equals to minus omega square y. So this is the answer we got, right? Yes. So that is, acceleration of n is directly proportional to the displacement in magnitude, but in opposite direction. Displacement in magnitude but in opposite direction. So opposite direction means which is towards the center or towards the point, fixed point. In opposite direction, always towards the fixed point O in path. So hence the motion of n is simple harmonic. So we have differentiated the displacement equation, we got velocity, again we have differentiated, we got acceleration. In that acceleration it is directly proportional to displacement, but it is in negative. So when it is negative, it is directed towards the fixed point. Okay. So therefore the projection of uniform circular motion on any diameter is simple harmonic, right? You can take a note of this. So completed, we can go for the next one. Okay. So the next equation is in oscillation. Show that the motion of a simple pendulum is simple harmonic. So previous case what we have we have done a particle which is in a circular path, I need to show that whether it's a simple harmonic. Now simple pendulum is a simple harmonic, hence derive the equation for the time period. Okay, time period. So this is the equation. So we will try to analyze whatever they have given. Show that the motion of a simple pendulum is simple harmonic and hence they derive the equation for time period. Okay. So simple pendulum. So first thing we need to see the diagram. Let us show you the diagram. Okay. So this is the diagram, like it's a fixed axis is there. Okay, fixed rigid is there, support is there, and I have tied a bob with a rope or a string. So now if we take to extreme point, what will happen? Again it will come to the initial point, again it will get oscillate, right? It will be in oscillation, right? So from this, let me explain you the thing, how we got or what are the forces which is helping me to come back. Okay. So suppose if I consider this is the rigid support and this is my bob. Okay. Now if I take the bob somewhere here, okay, it will be oscillating, no, it will be in oscillation, it will be in oscillation like this, right. So the tension will be there, T, like away from the body, so making an angle theta, So when I talk about this, like there will be a weight, that is mg. So when I extend this, the angle I can write here, no, theta. So when theta is close to the axis, this is my mg cos theta and this is my mg sin theta. Now tell me that mg sin theta is helping or mg cos theta is helping me to come back? Mg cos sin theta is helping me, no? Yes. So mg sin theta is helping me to come back. Understood the diagram now? Now we will go for the thing. Okay. So a bob of mass m oscillating in a plane about a vertical line through the support is called a simple pendulum, okay, which is in oscillation. Let the bob given a small angular displacement theta. So they have given, like, let me draw the diagram here once so that it will be easy to analyze, right. So there is a bob and we have taken somewhere here and it will oscillate like this, okay, right. So let the bob be given a small angular displacement, bob given angular displacement, that is theta, and released. So then it execute SHM with displacement y and acceleration a, right. No, so at this point, I mean at this position B, we have taken this position as A, means this as B. Bob is resolved into two components. We have resolved, this is my sin theta, mg sin theta, and this is my cos theta, right. So mg cos theta produce the tension in the string, so it is tension, and mg sin theta is helping me to come back. So F is equals to minus mg sin theta produces the torque for oscillatory motion, right. Okay. So restoring torque pendulum. So torque will be is nothing but force, like F cross R, no. So the R, it's a position vector, right. So force we know mg sin theta minus mg sin theta into length L is nothing but the torque, a perpendicular length cross force. So minus mg, where we have taken the angle as small. When we are talking about the angle which is very small, either it can be sine, cos or tan, we will consider as a theta only. So theta. So torque will be equals to minus mg L theta. So it has been like the deflecting torque developed. So torque is nothing but moment of inertia into alpha, right? Moment of inertia into alpha. When I consider like this equation 1 and equation 2, right? So minus mg L theta and I alpha will be equal, right? No, I alpha will be equal. What is alpha? It is angular acceleration, angular acceleration. So alpha will be equals to minus mg L by I into theta, right? Now this is the acceleration equation, So equation 4 represent the pendulum executing SHM, So when we compare with alpha is equals to minus omega square theta, right? So omega square will be equals to mgl by I, because this theta and this theta will get cancelled, right? Now let me write here. So minus mgl by I into theta will be equals to minus omega square theta, minus cancel, omega square will be equals to mg L by I. So omega will be root over mg L by I. So we know that time period is nothing but 2 pi by omega. How 2 pi by omega? Yes, let me explain you that how we got the 2 pi by omega also. So when we talk about this circular path, circumference is 2 pi for one revolution, right? Now, so omega will be equals to angular displacement. How much displacement happened? 2 pi by t. So t will be equals to 2 pi by omega. So now what is omega here? Root over mgl by I. So if I substitute the value of omega here, 2 pi into root over I by mgl, it will be reversed. Okay. Now for a simple pendulum, I will be equals to ml square. So ml square by mgl, m will get cancelled, L square 1 L will cancel, So 2 pi root over L by G is the time period of the simple pendulum. Okay. So the second part of the question is, what is seconds pendulum? A simple pendulum whose time period is 2 seconds is called as seconds pendulum, right? So this is the second question answer of the oscillation. Okay. I hope it's clear, right? So now we have completed the chapter 1 and chapter 2, like 8 mark questions. Okay, work energy, power and oscillation. So when coming to the next class, coming before the next class, no, try to complete these 2 lessons, like total number of questions are 5. So we should be clear about that. Whenever they ask any questions in this 2 lesson, we need to able to answer. Okay guys, so with this let me conclude the class, right? So we'll meet in the next class. Bye.